Hello, 2025, Euclid problems first, and then we're gonna do Gauss grade 7 and grade 8. But let's start with Euclid anyways. The Gauss are not yet happened. Let's start with this problem 4a, which is a bicycle problem. Terry's bicycle has a larger front wheel with a radius of 15 and a smaller rear wheel with a radius 9. And Terry ties a ribbon at the top here and another ribbon at the top there. And Terry travels d centimeters forward and stops. Both ribbons are again at the top of the wheels. What is the integer closest to the smallest possible value of d with d over 0? Okay, that is to say, at last, the ribbon goes back to the starting place, both of them, meaning the front wheel has got several complete turns, and so has the back wheel, the rear wheel. Okay, so let's say this one is whatever you call m turns, complete turns. This is n complete turns. Okay, let's write them down. So we've got enough space here, I think. The front wheel, that is 15, the perimeter of the circumference is 2 pi times 15, and we've got, let's say, m, start with m complete turns. Okay, this is the this distance traveled by the front wheel. Of course, that's the same distance, so let's say that is d, and d can also be expressed using 2 pi times, what is the radius here? 9 cm. Okay, 9 cm. Wait a sec. 9 cm, but this time it's n complete turns. So they have different numbers of complete turns because, you know, this one is just larger. So fewer turns for this wheel. And that wheel, the rear wheel has to go more turns. But the total distance is the same. So we've got the stuff here. And we are going to find out the smallest possible value of d. So the first time this happens, to put it simple, and let's solve the equation over here. Let's forget about d for now because we are solving the relation between m and n. So easily 15n is 9n. You can discard 2 pi, and m over n or m to n, it's a ratio thing, it's 3 over 5, and that's it. But m and n are both integers, are whole numbers, because we are counting the number of complete turns. So the first time this happens, m should be exactly 3 and n is exactly 5, meaning d is, what is that? 3, you plug it in, 3, that is, okay, 6, 15, that is 90 pi. We are basically done, but we have to find out the closest integer. So do a bit calculation, maybe, I don't know, maybe the problem maker just want to test if you know that pi is close to 3.14, something like that, but that should suffice. So just use 3.14, it's okay. And that's 0, 4, okay. It's a 6, 3, 2, and 1, 28, 1, 2, and there's just one decimal place because there's 0. So that is, let's put the unit as well, cm. Oh, that's not a lot. That's not a lot, just like 2 meters something. So 282.6. And the integer would be, we should go up, 283. That is the closest integer to the smallest possible d. And the problem is done, okay?